Solving equations and then determining if the equation is conditional, a contradiction, or an identity. So first, before we worry about any of that, we simply solve this guy. So I need to remember that an equal sign in mathematics, this is indicating a sentence that is true. It is saying that this side of the equal sign is the same value as the other side of the equal sign. So this is my balance here. I need to keep that in mind. And if I add, subtract, multiply, or divide a new thing on one side, I have to do that same thing on the other side of my equal sign. Before I get to add, subtract, multiply, or divide new things, I need to simplify what I have. So I'm going to get rid of parentheses by distributing. This is a multiplication. Again, this is not a new thing. We are applying our law of distribution. So 4 times x, and then plus 4 times 5. That gives me 4x plus 4 times 5 is 20. This is as simplified as this side of the equal sign gets. This term has an x in it, this term does not, so they are not like terms. We cannot combine them. But I can go to the right side of my equal sign and simplify it. Again, there's parentheses. That means I can distribute to get rid of those parentheses. So I have 4 times 3 plus 4 times 2x. In this case, I also have this term out here. I need to make sure I don't lose it. So I'm going to go ahead and write it down here. Every time I do work, I rewrite the question. That is what helps me get a correct answer in the end. 4 times 3 is 12. 4 times 2x is 8x. And then I have that negative 4x that was already there. This side of the equal sign is still not simplified because I do have like terms. Now that I've multiplied across the parentheses, I have an 8x, and I already had that minus 4x. So I'm going to combine those like terms. The 12 stays the same. 8x minus 4x's gives me 4x's left. Now I'm rewriting the equation just so I know what I've got and I don't get myself confused. 4x plus 20 equals 12 plus 4x. Now we're ready to solve. We've done all our simplifying. It's my recommendation that we add or subtract to get x terms or y terms, your variable terms, on the left of the equal sign. And the reason I recommend getting them on the left is when you move to those inequalities, if you're solving so your variable's on the left, that inequality arrow will point to the direction that you need to shade on your number line. If you solve the other way around, you'll have to flip things in your head, which can be cause some complications. So add or subtract to get all the x terms on the left, variable terms, and then add or subtract to get all terms without variables. All constants is what they're called. On the right. So we simplify, and then we add or subtract to get the variable to the left and the constant to the right. Term without variable. You learn that in Module 8, but when they start throwing these crazy things at you, it can get confusing again. All right, so I am going to add or subtract to get my x terms to the left. I have an x term here, but I have one here too, and it is not to the left of my equal sign. So right now this is addition. That means to get rid of it, I will subtract it. This is when if I do something to one side of my equal sign, I have to do the exact same thing to the other. And I'm going to line it up with the other x term. Alrighty. So I have 12. 4x minus 4x is gone. That went to 0. Over here, 4x minus 4x is 0. And I have a plus 20. This is as far as I can go. I mean, I could do my next step and add or subtract to get all the constants, the numbers without variables, to the right. I'll just go ahead and do that. This 20 is not on the right, so I'll subtract it from both sides. That goes to 0, and this goes to, what, 8? Negative 8. Either way, 20 equals 12. Your brain's already going, something's wrong. Did I do something wrong? No, both of these are not true. When your brain goes, something is wrong, that is not the truth. She just said her favorite frogs are blue, and then she said her favorite frog is green. So this is an example of a contradiction. It is not true. Alrighty.